Hello everyone, today I want to explain about the acidity of carboxylic acid. This carboxylic acid in aqueous solution, it means in water, this will be form a carboxylate and water molecule. This is called carboxylate. This negative charge, if it is stable, if it is stable, then reaction forward direction. If it is unstable, then reaction backward. It means undissociated form. When it is undissociated form exists, it means it do not lose as a proton. Then it is a very weak acid. Weak acid. If it is stable reaction forward, meaning this acid is strong acid if it is a carboxylate and is a stable and reaction forward. Anyway, these carboxylic acids are generally weaker acids than the mineral acids. So acidity order is mineral acid. Mineral acid means inorganic acid. Mineral acid acidic nature is greater than carboxylic acids. Therefore, reaction generally little bit backward. That's why you observe here. This is a backward, this is a forward. Forward is less, backward is more is there because these are all are weaker acid than the mineral acid. Anyway, according to the equilibrium, these are the products concentration by reactant concentration. This is a pure liquid, that's why its concentration is does not change and taken as a unity, therefore here not represented. Then Ka value generally in the negative term sometime are very smaller or very higher value. Therefore, in simplification, we are using this pKa value. Then based on the pKa value, we can decide the acidic and basic nature. Then according to this, Ka value increases, pKa value decreases, that is called stronger acid. Similarly, reverse, Ka value decreases, pKa value increases, that is called weaker acid. Based on that, we will decide. Now here some carboxylic acids are given. One is formic acid, acetic acid, propanoic acid. For so these are the donor group. Methyl group is here, donor group. Ethyl is the donor group. So for example, this is a RC double bond O minus. So this is a donor group. If it is, then what will happen here? Electron donor already here negative charge. Negative, more negative, therefore unstable. Therefore, we want electron withdrawing group. Electron donor group means this negative charge unstable. Electron withdrawing group is that means this negative charge stable. So when reaction that anion is stable, reaction forward, and when it is unstable, this is a backward undissociated form exists. Therefore, we want electron donor group. According to this, electron donor group decrease the acidic nature. Acidity decreases. Electron withdrawing group acidity increases. That you have to keep in mind. Now, here without any donor group, here one methyl group and here ethyl group, donor group decrease the acidic nature, one thing. Now here formic acid and benzoic acid and acetic acid. Then generally aromatic acids are more acidic than the aliphatic. That also you have to remember now. Aromatic acids are more acidic than the aliphatic acids in general. So here we can say this aromatic, This is aliphatic. So okay, this is accepted, but aliphatic this is, but also more acidic than the benzoic acid because the pK value observed here. So reason, formic acid is exists like this after loss of H plus negative charge. Then in between this resonance form is, this is O minus and here double bond O. Now you keep in mind this negative charge delocalized here and this pi bond delocalized toward the oxygen. Then this negative charge present on oxygen, these are called equivalent resonance structure. But if you take for the benzene, then benzene will get, it means benzoic acid after loss of H plus, then this will be shift to here, this will be shift to here, and this may be shifted toward like this. Then negative charge delocalized over the carbon and oxygen, but here in formic acid negative charge delocalized over the oxygen only, therefore it is a more stabilized than the benzoic acid. That's why formic acid is more acidic than the benzoic acid, and you have to see their pK values also. According to the pK value, the relevant explanation is the formic acid has an equivalent resonance section and negative charge is present over the oxygen. We know that negative charge on the electronegative atom is more stable than the negative charge present on the carbon atom. Therefore, formic acid more acidic than the benzoic acid. Acidity of substituted benzoic acid. Now on benzoic acid, nitro group, chloro group without anything, methyl group. Now you have to decide electron donor groups. Generally electron withdrawing group acidity increases. Electron donor group acidity decreases. Now you have to identify, this is a electron withdrawing group. This is electron withdrawing and donor both. So here electron donor group, electron donor group. But majority is due to resonance, it is electron donor group only. Chlorine is generally majority due to resonance, it is donor. So here electron withdrawing nature also because of electronegativity of the chlorine. Now electron withdrawing nature increase, acidic nature increase because that negative charge is stabilized by the electron withdrawing group. Therefore, according to this pK value 3.41, 3.98, 4.19, 4.36, this is the order. This is a order because electron withdrawing groups are, strength of electron withdrawing group increases, acidic nature increases. NO2 and Cl both are withdrawing nature, but strength of the electron withdrawing NO2 is greater than the Cl. So here methyl group is donor than the here without group. Therefore benzoic acid is more acidic than the para methyl benzoic acid. Now coming to the next one. Here nitro group present, formic acid, Cl without and methyl group and acetic. Now all together mixed here. According to this pK value 3.41, 3.75, 3.798, 4.19, 4.36, 4.79. In general, we know that aromatic are more acidic than the aliphatic. So this is aromatic with the electron withdrawing group. This is more acidic. Here formic acid, this is, it is equivalent resonance is already shown. So chlorine is both withdrawing and donor, more donor respect, thus it is less acidic than the formic acid. And anyway chlorine is withdrawing little bit than the benzoic acid, that's why parachlorobenzoic acid more acidic than the benzoic acid. Then benzoic acid already here studied, benzoic acid more acidic than the which one, para methyl benzoic acid. Now this is acetic acid. Anyway here donor group is there, here also donor group is there, but aromatic little more resonance stabilizer, that's why para methyl benzoic acid is more acidic than the acetic acid. Now acidity of this substituted benzoic acid, other form these are. So now keep in mind these are the electron donor group here without. NO2 group electron withdrawing group. This is electron withdrawing group. Here also electron withdrawing group. Now coming to the point, NO2 in three different position electron withdrawing group is there. Due to ortho effects, this is more acidic nature. Anyway, para position, the after loss of H, after loss of this H, the resonance form is more stabilized here through meta. This is through meta position withdrawing or donor, the formed anion or cation is less stabilized. That's why less withdraw, it means that is not more favorable resonance structure, therefore less stabilized, therefore meta is least compared with the para. Due to ortho effect, then ortho is more stabilized form, therefore here it is more acidic than para. After para, next meta position, here benzoic acid without any withdrawing group is there, therefore this one. Anyway, this methoxy is the donor group, therefore least according to their pK value: 4.46, 4.19, 3.47, 3.41, 2.16. So due to ortho effect, ortho position of any donor group or withdrawing groups are present at ortho position of benzoic acid, that is more acidic. Keep in mind what is the ortho effect mean. At ortho position, electron donor group or withdrawing group, irrespective of donor or withdrawing group present at the ortho position of benzoic acid, that is more acidic in nature. Acidity of dicarboxylic acid. Oh my such good apple. O mean oxalic acid, my mean malonic acid, such means succinic acid, good glutaric acid, apple adipic acid. So oxalic acid mean what is the COOH, COOH. So here two COH are there. First time H loss mean pKa1, second time loss mean pKa2. So I given here pKa1 values only. So this is 1.27, 2.85, 4.19, 4.35, 4.43. So now you observe here without any in between COH, no any other carbon, but here one extra carbon, here two carbon, here three carbon, here four carbon. 111 methylene group CH2 groups increases. CH2 group increases. Acidic nature, what happened? Acidity decreases according to pK value. You can observe here. So, oh my such good apple. Oh, oxalic acid is more acidic than the other remaining acid. So, acidic nature 11 CH2 group increase means acidic nature decreases. One of the very important question for acidity of dicarboxylic acid is malic acid, fumaric acid. So now this is malic acid cis form, because this HH are same side, COH are same side, therefore cis form. This COH is opposite, HH opposite, therefore this is a trans form. Now cis form is more acidic or trans form is more acidic, because when that structure changes, name also changes here. Observe here, just the simple thing is, in case if this hydrogen loss, then this is which one? Negatively charged. This negatively charged bond form, hydrogen bond form here, therefore it is stabilized. Due to hydrogen bond, it is stabilized, because the formed anion should be stabilized, then only that is more stronger acid. And here if it is loss also, these are away to each other, therefore no hydrogen bond formed between the negative charge and hydrogen, therefore it is less stabilized. Due to hydrogen bond, it is stabilized, that's why it is stronger. This is a weaker acid, here 3.02, here 2. That is the difference why malic acid is more stronger than the fumaric acid. These are dicarboxylic acid on aromatic ring. So here 1 2 position we have the 1 and 2, here 1 2 3 4th position, 1 2 3 position. So 1,2 position name called benzene 1,2 dicarboxylic acid. IUPAC name is benzene 1,2 dicarboxylic acid. Here 1,4 dicarboxylic acid, 1,3 dicarboxylic acid. Common names are generally used here. Therefore, this is phthalic acid, terphthalic acid, isophthalic acid. Therefore, if here the case also same. In case this hydrogen is lost, then what happened? This negatively charged is stabilized here with the hydrogen bond. So hydrogen bond is there mean that is stabilized. Stabilized condition means that is somewhat stronger acid. Now here if loss means there is no hydrogen bond form, that's why terephthalic acid phthalic acid is more stronger than the terephthalic acid. And already I told you that through meta position, now it is electron withdrawing group. Now electron withdrawing group. But at meta position less withdrawing nature than the ortho and para position. The formed anion is more stabilized in ortho and para than the meta position. That's why it is a least stable, therefore least acidic nature. According to the pK value 2.96, 3.54, 3.62. So keep in mind 1,2 position more stronger than the 1,4 position, 1,4 more stronger than the 1,3 position. Now acidity of substituted carboxylic acid. So these are very important. Here you have to remember here inductive effect also applicable. Inductive effect applicable. Minus I effect increases, acidity increases. Minus R minus EM increases, acidity increases. And these groups, electron withdrawing groups, are close to COOH group, then acidity what happened? Increases. These are the condition you have to keep in mind. Now here observe 3 fluorines are present. Actually what is here? Just this is a CH3COOH. Instead of this hydrogen, here 3 fluorines are present. So 3 fluorine mean more negative. It means electronegativity increase, electron withdrawing nature increases. So observe here arrow are given upward, stronger acid. This is the most stronger acid because inductive effect increases, acidic nature increases. Next to chlorine, next to 2 chlorine. Here 3 fluorine, 3 chlorine, 2 chlorine, and NO2 group, CN, fluorine, chlorine. Up to here you can understand electron withdrawing nature increase, acidic nature increase. Now distance related. Now this is the next alpha position. So keep in mind electron withdrawing group, electron withdrawing group at alpha position, acidity more. If beta gamma is acidity, what happens? Decreases. So this is a functional group COH. Next carbon is known as a alpha carbon. So keep in mind this is a alpha carbon, this is a beta carbon, this is a gamma carbon. So at alpha carbon means electron withdrawing nature more. Now bromine, compare with the chlorine, bromine electron withdrawing nature less. Next iodine. Next this is sp hybridization. Sp hybridization means electron little greater. Compared with the iodine less, that's why less acidic than the iodine substituted acetic acid. So you can observe their pK value. So based on that you can clearly understand. I am also explaining that what group and what type of nature this is. Uh, Here methoxy is two type. Here donor also, withdrawing also. Here it act as a inductive effect. Here it act as a minus I effect, withdrawing nature. Then hydroxy, then chloro. Chlorine at present at which position now? Observe here this is alpha, this is beta. So distance increase mean electron withdrawing nature decreases. Next, this is alpha position. What is there? Benzene. Benzene, all these carbons are which one? sp hybridization, sp hybridization, sp hybridization. Sp mean what is that? Electronegativity increases. So you can keep in mind electronegativity is sp2 sp2, sorry, I wrote sp here, sp2 because double bond character, sp and sp2 here, then sp3. So benzene has a sp2 character, therefore it is more acidic. And now here also is there but two carbon, but here number of carbons are sp2 hybridization. Now if you compare here, this is alpha, this is beta, this is gamma. Distance increase means acidic nature decrease, then acetic acid. Then one thing you have to remember here, this is two carbon. How many carbon? Two carbons. Here how many carbon? 1, 2, 3, 4 carbon. And here how many carbon? 1, 2, 3 carbon. So little difference is there in their acidic nature, but also carbon increases here, little acidic nature more for butanoic acid than the propanoic acid. That is based on that Ka value measures experimentally, but normally carbon number increase, acidic nature decreases. So here all are acetic acids, but at alpha position we have NO2 group. So based on that NO2 group here, this is electron with all are electron withdrawing group, electron withdrawing group, electron withdrawing group, and here electron withdrawing also, donor also. So step by step what happened, electron withdrawing nature decreases, therefore acidic nature also decreases according to the value. And this can be act as electron donor group also because the lone pair present. So keep in mind 1.68, 2.46, 2.86, 3.83, 4.74. So when resonance is there, it acts as a electron donor. When resonance not there, due to electronegativity, electron withdrawing group. So step by step what happened, electron withdrawing nature decreases, acidic nature also decreases.